Okay. Hello.
Hello.
Discord, right? Discord. Okay. So, do you guys have the graphics, the figures from yesterday?
Yeah, I've got something.
Okay.
Can I go first? Why not? Give me a minute. Let me share my screen.
One sec. There you go.
Okay. Thank you. All right. Okay, you can see my screen, and this is the thing that's relevant right here. Okay. I mean, I've tried all of these. Liz sample, and I made a wave file
Mm-hmm.
like Liz sample 1 and Liz sample 2, and these are the wave files otherwise that Tony gave us. And this first program, you can see that we get something, okay? And these are the end of it, of which I took a PNG picture of.
Mm-hmm.
And that's for detect voice activity example. And so that program was up and running, for a while. That's okay. This is the one that like Kong and I worked on yesterday. And we finally got it to run with a little bit of finagling. And as I posted yesterday, this was of the HAL right here, and it's good. And then I did it yesterday of this S101 mic 3. We got something, and we got something for experiment 4 mic 3. So that's good. And then we have a output file of ones and zeros. So that's all fine and good. Now, the thing is that, and this goes for both Kong and myself, is that we took this Liz sample 1 and we ran it through that example, and the program failed. There's something like some concatenation error of matrices and all this.
Mm-hmm.
And the thing is that I did it independently and Kong did it independently. And we talked to each other last night, 7 o'clock or 6 or something like that. And he said, "Well, mine doesn't work," and I'm there, "Well, mine doesn't work either." And then, speaking with him, because like all Sunday afternoons, "Why doesn't this work? Why doesn't this work?" And then speaking with him, it's like, well, maybe it's not supposed to work. Maybe it just failed because on these Liz samples, it's a very noisy background. Maybe even the noise is more prevalent than the speech.
Okay. Can I see the error?
Yeah, okay. All right. I will bring it up.
Mm-hmm.
Okay. I'm sorry I don't have it ready, but I was looking at the statement of work that Ahmed sent to me, and it's getting better. It's getting thicker, and I tried to make some corrections, and I just posted it in what is it, Discord, and so here we go. So okay, yeah, this is the right one. Okay, and then this is the right file. Come on, you silly thing, move. Come on, where is it? Well, you see, that's my computer. Okay, there it is. And then at the end, there's a text file, an output text file, and just these simple steps. So, like I said, this program worked for other files, but let's run it. And why does it look like it wants to work today? Isn't this the strangest thing? This MATLAB, it'll drive you nuts. Because yesterday at about this time, it would already fail. But look at this, it's working. I don't believe it. I hate MATLAB because it is so picky.
I see. Okay. Can we like work on this later because I'm
Okay, there it is. There's my error. There.
okay. Bradley, that is an error from MATLAB. If it's not supposed to work, it means that the output that you have. Actually, let me put my camera. Maybe like it will be like more personal.
Yeah.
Hi, this is me.
Okay.
Okay, so maybe there's a problem with the code and the formatting, particularly the input format, the input audio. If you have an error like that, then it means that the program is failing. If you show me a figure and you don't detect any speech in the figure,
Yeah.
then it might not work for all my audios, and it's fine. That's a failure.
Right.
But when you have an error like that,
The
I'm
MATLAB.
sorry, but you have to keep working on that. I mean,
Yeah. Okay.
mm-hmm.
Okay. Let me just wrap this up. There's some crucial. Here it is. You see,
Okay,
you
I
can't.
don't,
You don't
I
have time.
cannot go and fix the code.
Okay.
I can't.
All
I'm
right.
not
We'll
going to
work
go
on
there
it.
and fix every line.
Right. We'll work on it.
Mm-hmm. Okay, go for it.
Okay.
I'm going to open now the file that Ahmed sent, the project statement, so we can work for the next version. Okay.
Yes. I just put my own version. It doesn't brutally, you know. I mean, it's Ahmed's words and all this, but just a little bit cleanup. And I will stop sharing the screen so that Luis can.
Okay. Mm-hmm. Yeah, let's check this together. Day and age is reviewing the vulnerabilities. There is a very push on still just everything because of these huge capabilities doing.
Luis, are you familiar with the structure of the statement of work?
I checked a couple of them before from other group of undergrads.
So let me just say the executive summary, according to the instructions that we're given, is a summary of all the following sections. So the business need, the product scope, the project scope, all of that. So it should summarize what is the project, give a bit of an introduction, the background, why do we need the project. So this is the first paragraph that you could see. Second paragraph is the product scope, what we're aiming to deliver. But the product scope is not set in stone yet because it says we need quantitative measurements or targets in order to be able to say, oh, we've achieved that. We can't just say something like we want a fast VAD. It needs to be like a VAD that calculates within 0.1 seconds or whatever, something measurable.
Yeah.
So this summarizes some of that. And yeah.
Thank you.
So the product scope, we don't know. The business need, I think I've got it. We just need to understand who's the sponsor exactly. And I'll just elaborate more on the business need.
Okay, so in here for quantitative results, you will provide the comparison on any speech detection, and this particular comparison for the further like speech detection or speech recognition or speaker identification. This particular part for the providing the comparison and those results, we're going to work on that on the next semester. Okay, because in this case you will start comparing the actual output systems that probably Mario can give you one. Mario's is the other student of Mario's that I work with that are working audio, and we should be able by the end of the semester to give you a GitHub repository so for you to run and compare the results. So here what you will do is that you will compare the speech recognition and speaker identification with and without your system. And ideally, and those were the numbers that you will get. So with those numbers, the one running your system as part of the pipeline should perform better. So those are your numbers.
Hang on, so our numbers are going to be a comparison with our system and another system? Is that what you're saying?
Mm-hmm. With those
Okay.
numbers, and that's accuracy. Hold on. Let me put it here. Accuracy metric. That is a metric from artificial intelligence. When you are in deep learning, we have like several metrics. One of them is accuracy. There's some others like a confusion matrix and several others. But
So we need accuracy and speed, right?
Uh, in the particular case of Antonio's work, it might increase the speed. But I wouldn't go for that because you will have to run the whole system of Antonio, and that will be very hard.
Okay.
So Antonio will give you the reason why you start doing this, and after that, you just run a couple of like speech recognition or speaker identification the next semester, and you start comparing like with the outputs from your own system, and then you will get the numbers. Okay, voice. Que se identify. Cocktail party.
Does that make sense?
Not a lot. I mean, I'm not going to fix your writing.
Yeah, no, but isn't this Tony's project? He's essentially trying to remap from one audio file.
Exactly. That's my job here, in order to like be able to help you understand Tony's project.
Yeah. I'll do the editing and stuff. The technology, Tony's project. I was gonna say like we need to say what it's gonna be used for. To be honest, this sounds like a lot of like spy and CIA kind of thing. Like just put a microphone and be able to remap.
Yeah.
So would that be a plausible use?
Yeah.
Okay.
Usually we don't talk much about those things. Particularly me, I'm an international student, so I'm not much into the defense projects. But if you're into American citizenship and all these defense projects, yeah, of course. So then recreate the same environment in a computer simulation by mapping each speech interval to relevant speaker and position of speaker.
I'll work on the wording for that, but at least I understand what's the project, and we'll see what we could put down as a use.
I say it's good, and I understand what you're saying, but I'm sure the English teacher and all of us out there would say it could probably be put more succinctly. You know what I mean? Right? But it's like, I get it. I understand what you're saying. And, semantics and syntax and all the rest of that, you could work on.
Yeah.
Multiple speeches from several people through a single microphone. Yes. Appeared here. This is perfect. This is what you need. Yes. And then this is, I will call like this is performed or something like that by recreating the same environment in a computer simulation. So this is the objective. You got it right on. And then the way he achieved that is by running a simulation. Speaker. Position each speaker. Computer simulation. Let's actually go for with factors. Okay, so you need to add here the 3D reconstruction of the room.
Take out a C. There you go.
And what else? And the position. And the position of the speakers around the microphone. And that's all you have to say. You don't have to go further than that. You're fine. Of course, you will require a little bit more here, but this is the idea. You need the position of the speakers around the microphone. That's the input. So don't forget about that. You need to know the dimensions of the room, and you need to know where the speakers are sitting in the table. After that, you are able to separate them using a single microphone.
So hang on, the input that we're going to have is the audio file that we pick up from the microphone recording, and we need to know the size of the room, understandable, but the positions of the speakers as well, like how far away they are from the microphone.
Yeah, there is a tolerance there that you can actually include, saying that within a tolerance of I don't know how many, 20 centimeters, something like that.
Okay.
But you need to imagine a table, and you need to say who is sitting on the left of the table, who's sitting on the right, who's sitting on the front. It's not like that particularly 33 centimeters or inches away from the microphone in this position, but general sense on the table.
Spatial awareness. Okay, and then the job of Tony's project would be to just use the audio from the file and say the speaker one is speaking because he knows its location, right?
Exactly.
Okay.
Yeah. Usually, this problem is tackled by using several microphones. But as you said, in this case, you might use a single phone, and then that's all you need to get everything. So why this technology important, and what could it be used for? So in this case, you might want to cite Antonio's PhD work, because he will give you all the particular applications. So far, what you can say, surveillance, in learning environments. Bradley, you're better with English. How can you say that this will help for environments?
Well, I was thinking like historical significance or something like this. You know what I mean?
I have no idea about historical significance.
Well, what I mean is that if you record somebody, like let's say in the White House or something, then you can figure out where their positions are, where they're...
log. Yeah.
Black box technology, essentially.
Yeah, there you go. Logs for meetings.
Right. The product will be delivered, will be a new and improved voice.
This is a point which I didn't know the answer to, essentially. Why is our product going to be better?
Well, you tell me. You're working on that. You're supposed to pick the best one. You're supposed to pick the best one, and you're supposed to work over that improvement.
And how will we go? Because I looked at some of the Python code that we found yesterday, and to be honest, I don't understand it enough. But even if I were to understand it, we're going to take that code, and how are we going to improve it? You said we're going to be using deep learning and AI. So we're just going to design a better neural network of some sort?
No, usually what you will do in the case, if it's a deep learning, then it will be a lot of fun because you can start messing around with the architecture. So we'll actually put it here. If you choose deep learning, then you modify the inner architecture. If you choose a regular a non-deep learning approach, then you will apply pre-processing to that, or most likely pre-processing
What do you mean
to
by
the audio, to
pre-processing?
the input audio. Pre-processing means cleaning the audio, for example. Let's say that this is a classic. Let's say that you have um, and let's say that you know that there is an old person and a child. Then the frequencies are different, and in that case, you can like um, modify the code in order to make it work for these cases where you have kids against adults, males against females.
So essentially, just improve the code to make it more inclusive, like include more frequencies, be able to detect them, all that.
So in general, uh, customize the method. Noisy environments. That's all. That's in general. Measurable specifications. We need quantitative goals target because this will be how we'll assess the project success. The comparison. I mean, compare the results without your processing versus compare the results without your processing, and then you will see using a speech recognition method. In this case, actually, this is actually quite interesting. You require a speech recognition method that accepts phrases or long audio clips. Just have that in mind. You don't have to really dig into that right now because this is kind of your just the right for now. But be sure to say that you use speech recognition methods that uses long audio clips, like 3, 4, 6, 7 seconds. There's a particular name for that. Those are attention-based transformers. You don't have to go there now. You don't have to get into that, at least now. But those are the ones that get an audio and start extracting like piece by piece. So just have that in mind.
So our project success relies solely on our comparison with another system, like
the comparison of another system using. I mean, you will not get the output of your system. You will get the output of the actual application, and you will compare that output with and without your method.
Oh, I see. So we're just going to be refining the code we find online is going to produce an output, and we're just going to take that output and refine it even more.
Well, you will not going to refine it. That will be the input of another system,
which is our system, and our system will work on making that output even better and taking some noise out. Or
hold on. So let's go back. So you have the raw input, okay? Let's get I really like a white voice. It helps a lot. Let me say this thing first. Useful before I use. Okay. Stop sharing. Yeah. So you have, this is the raw audio, okay?
Yeah.
And then this is your system. And this is a final application. Let's change the color now. which is the up. So then what you will have is you put the raw output here, and then you get audio, and then you see the output. This is one way. And the other way will be you have the raw audio, and you take it into exactly the same application. The same. And then you compare these ones. This and this.
What is the U in there, in the top one?
Your method.
Oh, okay.
Oh. Okay, I see.
This is what you compare. If this one perform better, if one perform better than two output, you're done. You prove yourself.
So our project is to essentially make that part where just make one work better than two by any means possible.
Yeah, and this is an application from like a third-party application. Let me put it here just to make sure.
Yeah.
You don't touch this part. You don't touch this guy. This might be Tony. This might be my speech recognition system. Maybe Bradley's research. I don't know, but this is a third party, and this is both the same.
And is this third party, is it relevant to what Brad and Kong were doing last night by finding those programs?
No, what you are doing now is, so the idea is that this raw, the assumption, man, this whiteboard is amazing. The assumption is that this raw here is noisy. That is the assumption. The assumption that you're working on is that if you put complete clean audio through this application, these results will be amazing. If you put a noisy audio, like the one you have in Aolme, then you will have different type of results.
Okay, makes sense.
That is the assumption. So what we did last night, this was yesterday, was comparing noisy versus clean.
I see.
And the idea is that this will be very nice and this will fail. And once this fails, then you start working.
And the fact that the clean works much better, this is why we need the project, and this is the business need for our project.
The business need is that there is no solution for this. Let me put it here.
Yeah.
So there is no solution available.
Okay.
Yeah, definitely. Like the more we meet, the best thing takes. Should take a picture of this, just in case.
I got a what is it? Snip.
Yeah, same.
Snip and sketch.
Okay, let's go back to. Oh man, again. Okay. Project description. Yeah, you have to work with Bradley because I don't. You have to like set up some dates.
It's not the idea of the dates, it's the idea of the steps that we need. I'm not exactly sure what steps. So these are very generic. Statement of work, we got that.
Well, use the classic debugging. Classic. Like first, gather information, then literature review, what you're doing now. So available methods, comparison of methods, implementation. Then you will go for refining best implementation, test on third-party audio processing applications, fine-tuning the design.
Hey, Luis, wait a minute. get rid of one of those N's in tuning, okay?
What else?
No, that's it. I mean, the pre-processing before. There's a hyphen between pre and processing, okay?
We'll sort out the spelling and stuff later, but the methods, I think,
Okay.
at
You
I'm
least
mean
sorry
here?
for being nitpicky, but English and all that.
Man, this is, if you send this thing right now, you will be dead. This is just, we're talking, you still need to work on this at least one more time or maybe twice.
yeah.
We're just talking.
Hey, this approval stuff, or are we on number 5?
I'm sorry, what?
5. We're on 5.
Okay, let's concentrate on 5. Go ahead.
Advice in progress meeting, yeah, need access to audio files. No, you don't need that.
How come?
Because you can just generate your audio files yourself.
Okay.
Most resemble the audios used by Antonio's work. Yep. You need to generate those. You can just grab them from YouTube or something. It doesn't
Okay.
matter. Just make sure that when you listen to them, they sound similar, and then that's all. If you want to work with Antonio's work, Antonio's audios, then you will require an IRV, and that's like more complicated thing. So just don't complicate yourself. Use any audio.
You know, here we go again. I mean, we've got the lab space. We could just talk in the lab space or something.
The what?
We're going to be using that Aome stuff because Marius already sent us a few like forms and stuff that we had to fill out in order to be able to use data.
Yes.
So
but in order to present that data to third parties, you will require like just other audios.
Okay.
And also this is for you not to stop yourself, because you really don't need to work exactly with those audios, as long as the audios that you picked are here sound the same as the one that Antonio is working on, then you're fine, because both are noisy audios.
Okay.
Actually, I've been working on the last weekend on a Pyroom Acoustics simulator class, so you can put a clean audio and it will output a really dirty audio. I will give you my GitHub in some days.
Perfect.
So you can like generate over there. You can cite my work and Mario, and then you will have more reference for free.
Perfect.
Bradley, you were saying about lab space?
Yeah, I mean, here I go again. But if we need to make some audios, like us 4 talking, we've got Balu's lab, ECE 327. So
yeah, sure. I mean,
we could just separate each other out and talk or read a poem or something like that. Make some noise.
Up to you. That's okay. Don't worry.
Quick question. You were talking about references yesterday, and you mentioned them today. What do you mean by references exactly? Because I forgot.
Well, usually when you do a report, then you need to like reference like where you took this method or why this is important. So in this case, in this particular form, you don't have to, but trust me, you will end up requiring a reference, so getting some references.
Okay.
And yeah, that's it. I mean, I'll send this back to you.
Wait a minute. Go to that approvals thing, please. Yeah, we need names in there. Sponsor, technical mentor.
That would be with Marius and Tony.
I don't know, man. I don't know.
You don't know?
I don't know about that part.
You don't want to handle that?
No, of course not. That's none of my business.
Well, I mean, maybe we should put you in there too. You're a little technical mentor, besides maybe Antonio and myself. Marios is definitely the sponsor.
I'm a little bit like short on time because I need to meet Marios at 4. So you can discuss this
okay,
with more time.
Yeah.
Okay, now let's see what? I cannot stop sharing.
Let me stop you out.
Thank you.
Can you put that on Discord, what you just amended with your draft?
Yeah, sure. I mean,
Yeah, so we can share it.
okay. So what about the other methods? No, hold on. Let's go in order. It's only 4 minutes left, so we're fine.
We'll join
Mm,
again if we need more time.
The figures. So do you end up like producing some figures? Con?
Yeah, wait. I got the same problem with Brad about the code of the VAD,
Mm-hmm.
and but I tried to find another audio, and it worked fine with that. So yeah, I
So
mean,
you use some results.
yeah, I mean like with another audio, it worked for both method. It worked correctly, but except
Okay,
the
we need to see the figures.
yeah. So I need,
It's
I
not that
think
we
I
don't
need,
trust you, but
yeah, I know. Uh, yeah, let me open MATLAB. I think I will have to regenerate it again.
But in the end, I mean, it's supposed to work with the AOMI, like Liz sample one and Liz sample two, right?
Yeah.
Because that's what those are the
so my understanding was that there was two methods and there was two audios, which means four figures as an output. Two
Yes.
audios per method, two audios per method. And you're telling me that one method didn't work, which is fine because things don't work sometimes.
Yeah.
So,
I mean, it's not work. I think that's the same problem with the red code. I think that there's a problem with the code now, and I really don't know how to fix that. So
where we stopped last night because we
okay.
yeah,
So
I
then,
spent all night to fix, and then
my understanding is that you had the least audio, the audio that was from Aolme, one of the audios didn't work in either the two methods, right?
oh, it
yeah.
worked in one of them, worked in one, but not
Okay, so then I should be expecting a figure coming from the method that it worked.
Okay.
okay.
So we should be like expecting at least two figures from one method and
Mm-hmm.
then another one from the other method, right?
Yeah, I mean, I've got
Awesome.
that for you.
Yeah, that Brad showed you already.
Yeah,
Can
Yeah.
we see them
Oh,
really
you
quick?
want to see it?
Mm-hmm.
yeah. So
Okay,
Brad, can you share
all
your
right,
screen? It's way better than me.
I'll take it. Yeah, let me share.
You can share.
There we go. That's like Liz. That's Liz sample one, and that's from detect voice example. And it gives what it says, it's a time scope, and it's just time
Mm-hmm.
and amplitude, and
Yeah.
it gives audio too. And so and this is it's like the signal of who's speaking and some noise in the background.
Yeah, it's clearly not working because it's telling you that everything is a speech, and that's not true.
Yeah.
Okay, next one.
Okay, well, what I have here is like Liz sample two, which is the same thing. I mean, you know, it's a
Mm-hmm.
time scope, time and amplitude.
Yeah, that's good.
Yeah.
It's
And
horrible.
it's like this is longer, but this is like the tail end of it.
Yeah, it's fine. I mean, you are not going to process 24 minutes of audio. You only need like 5 seconds or 7 seconds,
But
maybe
this is
10.
good though, isn't it? Because it showed.
That is failing exactly. It's really
Yeah.
good.
Yeah. Okay, but
It means that you have some space to breathe, some space to live.
yeah.
Next one, 50 seconds. Come on.
Okay. This is Hal, but Hal is good.
How is easy, of course. Yes.
Yeah, because the voices are separated out. The computer,
Mm-hmm.
there's not much noise.
Awesome. Yeah. That's
So
good.
that one works. And
Yep.
then the VAD example of the same thing, that one works. You see what I'm saying? But the VAD example is failing
I see.
with the Liz sample one and Liz sample two. And what Kong and I figured out last night is because it's so dang noisy, the environment, but the program can't pick it up, can't distinguish. And maybe that's what's happening in the program. You know,
My
besides,
understanding is that even if it's noisy, then the program will should give you garbage, but at least the program should not have an error.
yeah, well, I mean,
Man.
Yes, I
There's
mean,
Pong.
okay. So what I can see from your figures is that yes, you're on the right track. You prove it. It doesn't work in Aolme. That's really good because now you have some space to start working.
Right.
What you will do is that you will take the figure that is from the same method, of course, the figure that is failing, the figure that is actually like achieving that thing from HAL, and then we'll put it on your report saying those are preliminary results on why this thing is important because the methods that are available does not work in noisy environments.
So put that in the statement of work.
I am honestly, I don't remember because the last time I checked these seniors project design documents, I remember I have to like sign like four of them. So I don't remember in which one of them actually you can include
In the
some.
document that you were talking about is the statement of work, and this is essentially a contract of what we're going to do step by step, why
I
it's
see.
needed, and all that. So
I
should we
see.
put it in that?
No. Don't go into the contract. That doesn't matter. Those might actually be going directly to your Friday's presentation. So
Okay.
yeah, you're good. Those don't if they don't require those on the documents, then you're fine. Go for the Fridays. The other thing that is important is that you have to figure it out why it's not working in MATLAB. But don't give that many hours. Just I will go for like 2 hours and a half, maybe 3 hours top this afternoon, trying to solve the other MATLAB method that is not working. If that is not working, then you just have to move on. Ahmed, I already told you before how to set up the Conda environments. There was
Yeah,
the
I'll be doing that. Yeah.
homework zero. Please share that information and make sure that for tomorrow you at least have tried to implement one or two models because trust me, they will fail. So you might try four of them or three of them, and one of them hopefully will work. So you need that to compare.
So you want me for tomorrow to do homework zero and implement those Python with some of the audio?
Yes, try. I remember there was one GitHub that I believe Anne Tran was the one that sent it over the Discord yesterday, and it seems that in order to install that method, you only need to do like pip Python something and then install the package. I
Yeah,
will
this is
try for
where
that one.
we
That's
this is where we struggled actually. We couldn't get pip is not recognized as a command. Python is not recognized by me even though I have it downloaded.
yeah. Don't worry, man. Those are like
Sim-
yeah, those are
Technical.
very simple mistakes. Of course, everybody has suffered to that. Don't get me wrong. Everybody has went through that. I mean, a lot of times. But I mean, those are the classics. Everybody suffered through that. You have to like just
We'll try and get them done for tomorrow. Yeah.
yeah. I mean, you open Google and use that. That's it. If you have a particular problem, let's say that your TensorFlow is not running, or you have a package. How do you say? Um, a problem with one package being non-compatible with the other package, then give me a call, and then we can see uh, out of the blue what can we do. But problems with Python and environments and everything, all of that information is in the internet, and everybody has to go through that.
Okay, so for myself, I'll be working on that statement of work again, refining it for tomorrow or Wednesday, as well as work with on implementing, working with those Python and actually getting some data off of them.
Yeah, the idea is that you have to replicate the same experiment, getting noisy audio and um, getting a clean audio because remember you only have one method working. That's good, but that's not enough. You need several of them to compare and prove which one is the best. So
Okay.
mhm.
I'm sorry I didn't give him homework zero from the very beginning. But
Oh, it's okay.
yeah, and you're missing a package or two, and that's why pip doesn't work and things like this.
Yep,
So
I'm pretty sure you guys can figure that out. That just takes Google and a lot of patience.
Okay.
Mhm.
right.
The only problem with these packages, and I can tell you right away, if one of those packages requires you to install CUDA, CUDA, CUDA libraries that
Uh-huh.
actually are the ones that provided by NVIDIA to run on the GPU, then we have to meet again because CUDA is very tricky, and you might lose there like at least 10 days. You don't have 10 days to lose.
Oh, geez.
So
Okay.
in that case, I will have to help you, so we can fix it in like 2 or 3 days. But
Okay.
Can I
hopefully, none of the methods will require you CUDA. Otherwise, it will be like a week lost.
share my screen one more time?
Yeah, one sec.
Okay.
Okay, here we go. Yeah. Okay, I'm sorry to talk code, but you can see that this line has to do with a subroutine,
Mm-hmm.
and this has to do with our code. And it's like, I don't know what's wrong with it, and I think Kong might be running into the same problem. And so we'll have a look at it, but it's like what you said, we just can't spend hours on it, and I don't know who the guru is who's going to be to figure this out. But it just might not like the audio when it all comes down
Have
to it.
you? I mean, have you tried Google that error?
Yeah, I did. Spend my like it's like two magic is not the same size, but I don't know how the code working, so I cannot fix. I cannot make them have the same size with the magic.
Well, in that case, you have to use a debugger. You have to get into the code and print and see the variables and see where does the variable is not matching, and use the other audio. For this, I will tell you that be sure that both audios are in the same format.
Okay.
Okay.
All right.
If
Maybe
the audio that you have is already working, then maybe the format is different, the type of encoding is different. So my understanding is that you extract the MP3, a WAV file from a video using maybe a tool like FFmpeg, right?
well, I actually used it's called a Windows converter. So I
Yeah,
downloaded
okay.
it.
You might want to check into that process, because actually what you should do is that you should get another audio, find a noisy audio, and God knows where you're going to find that audio. The
Right.
internet, like libraries for testing,
Right.
pre-processing or something. Just get the audio and run that audio through that system, through that method. If that thing works, then it means that the problem might be on your method to convert from video to audio.
Yeah. Maybe there's something wrong there.
Yeah. So
You know.
again, check FFmpeg, and there is a command line. It's one line for MP4 to WAV file. So go there.
Yeah. In Audacity or something you're saying, or some program.
No, FFmpeg. That is
Yeah.
a library.
Yeah. Okay. I was trying to do it on Audacity, but that's where it failed because it was looking for that FFmpeg library, and
Well, you have to install that for Windows. Mhm.
yeah, I didn't do it. I couldn't do it. I didn't know how to do it. So, but I think you're on the right track. You're saying something there. So, I got to find out how to do that, how to install that library, and maybe it'll give the right, because there's a lot here, making sure it's, like 48,000 or something like that. And so,
The 48,000 is the sampling. And if you don't get the right sampling, then the audio will be distorted, but that's a different problem. The FFmpeg is a library that you can install on Windows by putting like next, next, next. Actually, you should go into like right now into Google, type FFmpeg,
Wait,
and let's divide now your efforts. Bradley, you install the library manually on Windows and use Audacity, and Kong, you go and try to use a terminal. And you know what terminal is, right? Are you familiar with that?
which one?
A
Oh.
terminal.
Yeah, quiet,
Power line.
terminal in Windows.
quiet. Yeah.
Yep. So can you show me your screen so I can actually like show you better?
See, I've just Googled FFmpeg, and then there's a download and all this, and so I'll have a look at it for Audacity.
Okay. Yeah. Let me show my screen really fast, because
Hey, let me get out of my screen. Hold on.
this might save you some time. Let's see. Let me make it here. Okay. FFmpeg convert MP4 to WAV. I have this exactly same command in one of my in another in this computer actually. If I'm like take long enough,
MP4 while preserving the highest possible.
yeah, you will require the highest possible for sure. I'm sorry, he is calling me.
Hey, An, we have to work on our Python stuff tonight, yeah?
Okay, so we can meet at the same time as last night, right? Okay.
It's going to be late in the evening for me because I have a lot of other stuff to do.
Okay, so do you, when do you want to meet?
I'm not sure yet. I'll text you, but we need to get that Python. If you could do homework 0 whenever you can, even before we meet, because that's setting up the Python environment.
Yep.
And then, yeah.
So okay, so just send me a message when you are free.
Okay.
And we will, okay.
And I can say the same thing to Kong. We'll communicate by Discord. And if we meet later on tonight, that's okay too. And I've got Marios at 3 p.m. So he has him at 4. I have him at 3. So just want to give him a good report. That's all. But I think we're making progress. So that's what he wants to hear. So
Yeah, let's hope we meet those deadlines for Fridays. This Friday and next
Okay,
Friday.
guys, sorry, I'm back.
okay, Luis, go ahead.
Okay, so this is FMMPEG convert MP4 to WAV. Then here, this is the one. This is the input, and then the output will be dot WAV instead of MP4. You have to, of course, read a little bit more of FMPEG. It's a very powerful library.
So that's a Python command right there. It looks like.
No, it's a library that runs here on one of these. Hold on.
On the terminal?
Yep, on the
Okay.
terminal.
It runs on the terminal. Okay.
But not only on, but this thing does not only runs on Linux, by the way. This thing also runs in Windows, so you should be fine. Okay, and you know what? Let me give you that code because I know I have the code. I know I have it.
I could take a picture of it. The snip and sketch.
How? No, I'll send you the code. Don't worry. I think it's this one, and maybe this one. Yeah, maybe it's this one. Let's see. Nope. Give me a second.
Yep. It's okay.
Maybe this one. Yeah, this should be the one. Okay. FMMPEG in WAV. No. No. This already downloads everything in WAV, and you don't need that. You need the MP4 to WAV.
Right.
No, this is not the one. So you have to work on with Google. Google is your friend now. I believe this is the fastest and safest way to convert. Usually we use this to convert like between 3,000 and 4,000 audios per run. So you should be like good to go if you want to run 1 or 2 with this. It's very efficient.
I like that. Where's that? Where is that? Yeah, right there. Right?
What?
Okay, I just captured it. The FFmpeg -1 input.mp4.
Yeah. Kong, Bradley, work on this. There shouldn't
We'll work on it.
Yeah, I can do that.
Nice. Okay, guys. I have another meeting with Marios, so
Thanks, Luis. Appreciate it. I think we know what we're doing. And we meet tomorrow or Wednesday?
I will say tomorrow. Otherwise, you won't make it to Friday.
What time?
1 p.m. works again.
Yeah. I've got ECE 419 at 2 p.m. and I've got Mario's today at 3. but 1 p.m. tomorrow works, okay?
Awesome.
Com,
See
does
you.
that work?
Yeah, I think so.
Mhm.
We have class then, don't we?
But if
Yeah,
you
I
get
can record.
into any trouble and you cannot like move, just give me a call. I mean, you have to move on this.
All right, 1 p.m. then.
We'll work on it tomorrow at 1. See ya. Thank you.
Bye.
See you.
Okay. All right, guys.
Uh, we have to go to class now.
Okay. All right. We'll see you tomorrow at 1 p.m. Okay. If not tonight with our individual meetings. Okay.
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 Okay. All right. Thanks, guys.